what we're going to do is we're going to do the recording here now, and we're going to start with intraoral imaging, and I'll try to keep it brief, and if I can get it small enough I'll send it. So we want the source of the X-ray to be as small as possible. We want it to be as far away from the object, i.e. the tooth, as we can, and obviously effective. I mean, you don't want to have super high radiation and shoot it from the other side of the room, so it's always it's a balance. We want the tooth, so that way the beams will hit the tooth in a parallel fashion. And then we want the X-ray film that it's going to record after it's gone through the teeth to be as close as possible to the tooth, because if that distance is too far, then you're going to envelop the entire tooth with X-rays, and that will cause a mess up in the clarity and in the focus. And ideally we want to create a situation where the film and the tooth is as parallel to each other as possible. Now, this is not always going to be possible, and which is why we'll talk about the bisecting angle technique. So the key 5 points: smallest source, and the source to object distance should be as long as possible. So small and long, like a rifle and a bullet. And then the object to the film has to be as short as possible, and then the receptor long axis should be parallel, and the tooth should be parallel to each other, the receptor being the film. And then the X-ray should be directed at the center of the object and perpendicular to the film packet. So you want to hit the arrow or the bullet right to the center of the chest. Okay, so those are the fundamental 5 principles. Next point is that we've got what are the sources and the risks of the radiation. Well, there's primary, there's secondary, there's tertiary, and the primary one is going to be the radiation that you get from taking the X-ray in the first place. It's shot straight at you. The secondary is that which bounces off the walls and the roof and the ceiling and the floors and then of the chair or whatever, and then comes and bounces at you. That wasn't specifically aimed at you, but it was bouncing back at you. And then the third is whatever leaks out of the X-ray box itself. Now that number 3 should be minimum or nothing, and number 2 is almost nothing, because we've got these long tubes, which are the culminator tubes, and that reduces it. And so that's fair enough, and that speaks for itself. Now, so as you've got it again here, you've got these the ideal focal spot as small as possible, focal spot distance to object as long as possible. The distance from object to film, I'm just going to summarize that little thing right here and put it into the slide. Okay, that should do it. The different types of intraoral X-rays we can get. We basically get X-rays which are periapicals, bite wings, and occlusals. And I don't think I need to go over what the purposes are. Primarily periapicals, you must always get the root tip and the crown. Bite wings, you're going to get the upper and lower teeth. They're biting together, separated by maybe a cotton roll, and a film gets half the upper teeth and half the lower teeth. You don't see the apexes. They're good for interproximal bone evaluation for perio. They're also good for usage with the caries interproximally and for bone levels. And then your occlusal films are shot from underneath your chin or from above for the mandibular, and then shot from the top of your head down for the maxilla. I'll close a couple of slides for that just now. Occlusal maxillary film, and look at the angle that the X-rays come in. Now, you know already that if you don't have things parallel, you're going to get elongation. So maxillary film, occlusal film, are always elongated, because if you put the X-ray beam shooting right from the top of the head, now you notice in the picture that she's getting it from the bridge of her nose, and that means it's coming in at an angle of some 60 to 65 degrees. That's a correct occlusal film. Because that angle is not 90 degrees, you will get elongation of the teeth, and that is expected for an occlusal film. Imagine if that film was coming from the top of her head, her entire frontal bone would be superimposed onto the teeth and you see nothing. So when we take occlusal films of the maxilla, we're expecting elongation, as you see in the slide, and that's rather important. What we're going to do there is they tend to be much more parallel. because you can put the film in your mouth and you can put the X-ray cone right underneath your chin and you can shoot it up at an angle. And of course, the value of that is that you can see the position of unerupted canines that are buried within the mandible. Now, you will sometimes position it into different angles under the mandible such that you can catch and pick up these giant cyaloliths, as you can find sometimes, as I will show you there. And if it's straight up and down, all of your teeth are going to look like little round pies. But of course, because of your curve of Spee, you're going to have angulation of the lower front teeth to be slightly forward. And of course, you will find these large calculi inside the cyaloliths, as you can see there. And so you'll want to change angulations and do a couple of occlusal films depending on what you're looking for. And if you find a cyalolith and you take a second image and you can change the angle of it, you can actually detect the total size of it. Because remember, whenever you're taking an X-ray, you're just getting a two-dimensional image. Anything you're shooting at is like if you take a great big frying pan and squash everything together, or take a steamroller and squash everything together, so everything gets superimposed on it. Got the basics of the bisecting angles and whatnot of the intraoral film. I know it's a bit tedious, but I'm certain you get questions on this, because you have to understand when you get things elongated and when you get things shortened. And the answer to it is that the parallel beams that are coming at you, the X-rays that are coming at you from this source that has been culminated down the barrel of the gun, that tube on the X-rays at the barrel of the gun, it's taken millions of tiny bullets and shooting it in one parallel direction at you. Well, it's still a point source, but the culminator beam is there to try to reduce, to try to make it from a tiny point source. But because they're atomic, we're talking on an atomic level, it still does come at you relatively parallel if you're far away. Now, when that happens, you want to ensure that the X-ray beams that are coming at you in a parallel direction hit the film and the object as parallel to the long axis as you can get it. And so what your objective is that you're going to try and always get the beams that come in. So you want the tooth long axis and the film long axis as parallel as possible. Now in the mouth, that's sometimes very difficult to do, so we have to use a bisecting angle technique. And the bisecting angle technique, as I'm sure that these pictures associated here will show you, is that you have to look at the long axis of the tooth and the long axis of the film. And then you draw a bisecting angle between them, just the midway point of the angle. And then your beam, your X-ray beams, have got to hit that bisecting angle, that imaginary line at right angles. Not the film at right angles, not the tooth at right angles. If you hit the imaginary line at right angles, then you will get a true image. If you don't get the imaginary line so if you don't need the bisecting technique and you are able to put the film and the tooth parallel, there's no need for a bisecting angle there because there is no angular difference between them. And so then everything's in a straight line, then you get a true image. And what it's important that you understand is that if you see an elongated image, you must understand where and how the beam is elongating that image. Okay, and that's what I'm going to show you just now. Your X-ray beam has to strike the imaginary line. Okay, and if that imaginary line is struck anything less than a right angle or more than a right angle, it will either shorten the image or lengthen the image. And here you're seeing the X-ray beam. Forget about how it's striking the long axis of the tooth and how it's striking the film. The shortening or the lengthening is the angle that the red arrows there are crossing the dotted line. As you can see here, that's an acute angle. All of those angles on the dotted and the red line is causing an acute angle, and so therefore what is happening, it's making the tooth appear shorter. Now if conversely the red lines hit that dotted line at an obtuse angle, i.e. greater than 90, right, then you will have a lengthening of the image. Okay? And then you will have a lengthening of the image, but notice it is hitting the imaginary line, not the long axis of the tooth and not the film. That's the key thing. That it is important to understand that when you hit that bisecting angle that you've imagined, created in your head, flat at right angles, your image will be at right angles. And that's when your long axis of tooth and film cannot be parallel, as it usually happens in the maxilla for your intraoral picture. And if you come at an angle, and if you get that angle wrong, you will either get lengthening or shortening. And lengthening will be created if you have an obtuse strike of the red X-ray coming onto the imaginary dotted line, and a shortening will happen if you have an acute strike, smaller than 90 degrees, of the X-ray angle as the beam comes in. That you really need to know, because this anatomy, this is not about the panoramic, this is about the anatomy that you need to know that can show up in intraorals. So these sketches that are coming up are specifically for different anatomy that can actually reflect on a periapical intraoral X-ray on the maxilla and the mandible. And this you just need to know. But this is easy for you, Jazz. This is, you know all your anatomy anyway. You did very well in that in the beginning. And I'm not actually going to go into the panoramic stuff. I mean, I'll put it up here on the screen, but I'm not going to go through it because that's just a question of learning anatomy, and I think you've pretty much got that. So I think you need to basically, I think you've basically got that, okay?